Hey, welcome back. We're going to wrap up this tutorial with one last chapter on irradiance particles. So what are irradiance particles? Irradiance particles is one of the newest features of mental ray. It's a brand new indirect illumination algorithm, which pretty much means that it's very similar to global illumination or final gathering. Pretty much does the same thing, creates indirect light bouncing around in the scene. Okay? Irradiance particles works different, however. It's a brand new algorithm and works totally different from global illumination and final gathering. Has its own unique way of working and solving indirect illumination. Okay, so let's go ahead and have a look at it. Let's open up an example scene here, and we'll open up number 9, scene 9, irradiance particles. Start. Don't save that. And if we do a test render, this is what we end up with. Pretty simple scene. Pitch black ceiling like before, pretty much the symptoms of a scene without any indirect illumination, which doesn't look that great, doesn't look very realistic. If we go to our render settings here, we go to indirect lighting. We're not interested in global illumination or final gathering. What we're interested in is importance and irradiance particles. Now, the way that irradiance particles works is it can't work by itself. It has to work with importance. Irradiance particles cannot work at all whatsoever without importance. So when we turn irradiance particles on, look at importance up here, it's grayed out. As soon as we turn on irradiance particles, there you go. Importance is automatically turned on. And it'll say here in parentheses, enabled by irradiance particles. So Maya will automatically activate importance as soon as you turn on irradiance particles. So here's the default settings for importance. We already know that a default setting of a density of 1 is overkill for importance, and it's going to slow things down a lot. Now, the same applies to irradiance particles. These default settings here with irradiance particles are very slow to render. They're very good settings though. If you render this out right now at the default settings, you get yourself a pretty good render, simply because these settings are so high up, even though you may not think it because it's the default settings. And traditionally, default settings are usually not very good, but in this case they are. In fact, they're too good, to the point where rendering would be extremely slow if we tried to render this out. So we're not going to do that. Instead, I'm going to show you what these different parameters do, how they work together, and how to tweak them and play around with them so you can do fast test renders and get yourself a good, decent quality render in a reasonable amount of time. Okay, so let's go ahead and let's get started. First thing I'm going to do is turn off irradiance particles, and I'm going to go ahead and create a physical sun and sky system. We already saw how to do that a while ago, so it should be pretty familiar to you by now. And of course, let's close that, and let's close that. And here's our sun. I'm going to move the sun up just so it's easier to work with. I'm going to scale up its icon too, and I'm going to rotate it around. Maybe I'll rotate it this way. It doesn't really matter how it's rotated, as long as it looks like pretty much a midday afternoon. So I'll render that out, and it's doing final gathering. If you remember, when we create a physical sun and sky system, Maya will automatically activate final gathering for mental ray, but we don't want that. Which brings me to another key note here. Irradiance particles cannot work with final gathering or global illumination. If you notice here, irradiance particles is grayed out. I can't use it. And what it says is it's disabled by final gathering. So I have to go to final gathering first and turn that off, and then I can activate irradiance particles, because they can't work together. They're different algorithms. You can't combine them like final gathering and global illumination. Irradiance particles only works with importance, and that's it. It doesn't play with global illumination or irradiance or final gathering. Okay, so irradiance particles is on. If I try to do a render now, you're going to notice down here in the status bar, we're going to get some different stats down there. It's doing the important emission first. Now the important emission is going to take forever because we have a density set to 1, which is way too high. Okay, after it finishes that long important emission, it's going to render out the irradiance particles, and that's going to take forever as well. Now, a lot of mental ray users out there for Maya, as well as other software that uses mental ray, have pretty much been complaining and kind of been at odds about irradiance particles simply because it seems like irradiance particles are too slow, and most people prefer just to use final gathering because they figure, well, final gathering works faster. It's not that final gathering works faster. It's that you're familiar with final gathering, and irradiance particles is so new that few people know anything about it. In fact, there really aren't many training tutorials out there or videos on irradiance particles out there. If any, I actually don't know of any besides the one that I'm making now. So what we need to do is carefully look at these settings, see which one does what, how they work together, and then you can start to optimize things, and then you can start to get results. Then you can start to feel comfortable as if though you were working with final gathering. So let's go ahead and do that. Let's get comfortable with irradiance particles. First thing we need to do is understand why irradiance particles take so long to render. There's two main reasons, and that is the number of rays and the density. The density creates a huge amount of importons. Because we have a high number of rays and a huge number of importons, we're producing lots of rays on top of lots of importons. That compounds on top of each other and really slows rendering down. So what we need to do, we need to lower the density down to something more manageable. Something like 0.1, for example, will be very manageable for test rendering. Rays we need to lower. If you were doing final gathering, you wouldn't be testing at 256 rays, would you? No, of course not. You'd be testing at something like 32 rays. Environment. This is a very important parameter. It's very important because it can really drastically affect your render time. Environment really slows down render time. If we turn it off, and it's on by default by the way, if we turn it off, rendering with irradiance particles is going to go by pretty quick. So let's go ahead and render this out now. And we can open up the output window. As you saw, the importon emission flew by almost instantly. And now we're doing the irradiance particles. The irradiance particles being rendered out. You can see it's going pretty fast. Not too bad. And there we go. Of course, we end up with a pretty nasty result. And the reason for that is there's two main reasons for the irradiance particles coming out this bad. And that is the number of rays is really low, and we're using a very small amount of importons. As if you remember, I mentioned that irradiance particles are completely dependent on importons. And if we have a small amount of importons, it's going to hurt the quality of irradiance particles drastically. So that's very important. If we look here, we scroll up in the output window, we'll see that we only shot out about 30,000 importons. I know it says irradiance particles, but that's actually referring to the importons. Okay, so we have about 30,000 importons, thanks of course to the density setting set to 0.1, and only about 32 rays. All right, well, we can improve this. This isn't a problem. Now we can make the importons bounce around in the scene using the max depth, the same way we did with importons when they worked with global illumination in the earlier chapter on importons. So I'm not really going to go over that because it's basically the same thing. You will notice, however, that the traverse option is disabled. This is because the irradiance particles are on. Because of the way that the irradiance particles algorithm works, you can't have traverse turned on. Maya will automatically turn it off because Mentoray cannot work with this option on if irradiance particles are on. Okay, so that's that. Down here, of course, we have the rays. Then we have indirect passes. What are indirect passes? Indirect passes is the same thing as when you come to final gathering, how you have the secondary diffuse bounces down here. It's basically the same thing, only it's the equivalent for irradiance particles. So the default is 0. That means that right now there's one indirect pass, the default bounce of indirect illumination in the scene. If we add an extra indirect pass by saying 1, we can render this out again. And let me save this image. I'm going to render that out again. Shouldn't take too long. Now, one thing to keep in mind is down here in the stat bar down here for Mentoray in the lower left, you'll notice that the irradiance particles will actually take a bit longer. Irradiance particles takes longer to render the more indirect passes you use. So I don't recommend using too many indirect passes. It makes your renders look nice, but it hurts you because it slows your rendering down by a lot. So you can see here, here's the first render, here's the second with one indirect pass. The first one took 17 seconds, the next one took 26 seconds. May not seem like a lot, but if you change that ratio, and let's pretend like the first render was a 1 hour render, the second render could easily be an hour and a half, hour 40 minutes. You get the idea. So the render time dramatically starts to increase as you have indirect passes. Also, when you increase the max depth and you start to increase the indirect passes, you really start to increase rendering time dramatically. So you want to keep that in mind. Now, the scale works just like the scale for global illumination and final gathering. It basically decreases or increases the brightness of the irradiance particles. Now, we only get a scalar value, that is to say, only a numerical value. We can't change the color of the irradiance particles like we could with global illumination or final gathering. We can only change the value amount here. So we can make it dimmer or brighter. All right. And let me go ahead and take that indirect pass and put that back to 0. Then we have interpolate. The way that irradiance particles works is by interpolation. It speeds up the render process through interpolation. Now you have two interpolation modes, always and secondary. Always means that all irradiance particle rays are going to be interpolated. Secondary means that only the secondary rays will be interpolated. What are secondary rays? Secondary rays can be rays that reflect off objects or refract through objects, things like that, secondary rays. That's not a good mode to use. I've found in my experience that it's not a very good mode to use. It's pretty slow, and it's just not as good as using the always interpolation mode. Now, if you want, you can turn interpolation to never. If we turn it to never, this activates what's known as a brute force method. Basically, the irradiance particles render out with no interpolation. So let me show you what it looks like, just so it makes more sense. It'll render out pretty quickly. As you notice, the irradiance particles rendered out fast. The problem is that it creates a big anti-aliasing nightmare. Because there's no interpolation, we can see the individual irradiance particles in our scene. And they're represented by these little dots. You can see these little speckles of light all over the place. Kind of makes the walls look like rough concrete, even though that's not the case. This is bad. This is artifacting here. Very serious artifacting we're getting here from the irradiance particles because we're using the brute force method, which is basically no interpolation. And the problem with using this method is that it takes a long time to render. It's not as fast as using interpolation, simply because now you create yourself a situation where you literally have an anti-aliasing nightmare. In order to get this to look good, you got to do a couple of things. One, you have to increase the amount of rays by a lot. So we can increase these rays to say 500, render this out again. Then portons are going to go by fast because it's only a density of 0.1. But now when it's rendering out the final image, it's going to take a pretty good while, simply because we're using so many rays to try to smooth out all that artifacting. And all the artifacting is not going to go away. It's still going to look a little bit rough. So what we need to do is increase the anti-aliasing in the render settings. But if we do that, we end up increasing the rendering time by even more. So you can see how this brute force method looks pretty nice and it's pretty simple and straightforward to use. You don't have to worry about interpolation or anything, but it takes a pretty long time to render, so it's very expensive. So that's a trade-off. You can already start to see a lot of the image, almost half of the image already. You can see it got pretty smooth out, pretty nice when I created 500 rays as opposed to only 32. But of course, as you can see, it's taken a long time to render. And that's with low anti-aliasing settings. Imagine if I increase the anti-aliasing settings, this will take forever. So I'm just going to cancel that render, hit escape on the keyboard to abort. It was already at 1:17 and it was barely even halfway through. So I'm going to turn interpolation back on. Very important. Now the interpoints, that's short for interpolation points. This works very similar to the final gathering point interpolation here. Very, very similar. Okay. Basically, it's going to look up, in this case, 64 irradiance particle points, and it's going to go ahead and it's going to interpolate those. So the higher this number, the more smoothing you get. Let me go ahead and show you how that works. Let me put this at about 64 rays. We were using 32 before. I'm just going to use 64. It's not taking very horribly long to render anyway. As long as it renders in under a minute, I'm pretty happy. So it's doing the irradiance particles down here, you can see in the lower left stat bar, which can take a good little while. Of course, we increased the number of rays from 32 to 64, so it's going to take a little bit longer. Not too bad, though, 26 seconds. I mean, you can't complain too much about that. Not too bad, less than half a minute. And right here, what we can do is we can change the number of point interpolation. Now, very important. If I do that now, I'll have to re-render the irradiance particles. Now, just like final gathering and global illumination, we have a map file option down here. So we can turn rebuild on or off, and it works exactly like global illumination. If you turn it off, we won't render irradiance particles again. So if I render this again, it's just going to render out the image, and it skips the irradiance particles because it's already saved as a map file, as a default. Okay? And I turn rebuild off. And I turned rebuild off. Now here's something very, very interesting about irradiance particles. By turning rebuild off, you can't just come in here and increase the amount of rays to say 500, and if you render again, it's not going to make a difference, because that's a parameter that needs the map to be rebuilt in order for the effect to take change. Okay? You have to rebuild the map if you increase the amount of rays. You have to rebuild the map if you increase or change the amount of indirect passes. You don't have to rebuild the map if you change the scale or if you change the point interpolation. So let's take the scale and let's drop it to about halfway and render again. And now you notice that it's a little bit darker. If I drop that to a very dramatic, very low number, the change will be very apparent. You see it's much darker. The only lighting in the scene right now is the lighting from the sun and the area light that's above this window up here. But you notice that the ceiling got very, very dark. That's because the irradiance particles are practically gone. So I'll put the scale back to 1, render again, and now you can see the irradiance particles taking place in the scene here. The point interpolation can also be changed without rebuilding the map, which is really, really cool. We can go ahead and set this to say 8, render again, and it's going to be very nasty. We're going to have lots of artifacting, as you can see. But we can come back here and increase this to about 128, and it's going to help to smooth that out a bit, get rid of a lot of the artifacting. Of course, we still have a lot of artifacting that's not going to go away. The interpolation here can't fix everything, okay? It does what it does, but you can't ask it to do more than that. Right now, to get rid of this artifacting, what we have to do is increase the settings, the quality settings for the irradiance particles. We're going to need more importance, so we have to increase the importance density, and we're going to need more rays. And we're going to need much more rays than 64. Right now, this is good for preview rendering, not good for a final render, okay? So what I'm going to do is I'm going to go ahead and end this video here, and in the next video I'm going to show you how to tweak this, and we're going to get this rendering real nice.